and technologies over the past several years, mainly focused on OpenStack for almost 4 years now. Let me introduce you to our speakers today. We have Ryan Pei, who is a Senior Program Manager at Pivotal. Welcome, Ryan. Thanks for joining us on this webinar today. There's one interesting thing you mentioned here in your bio. You said you were a former enterprise applications developer, but today you're doing Cloudfoundry. I'm just curious about what you think the difference is between an enterprise application developer and a Cloudfoundry developer. Can you share a few insights there?
Yeah, sure. This is actually a jump horizontally as well. I was a developer in my former life, and now I'm sort of a product manager for Cloudfoundry, and it is a very different set of problems. We're working with very large systems rather than just one-off apps. So this is a very interesting challenge.
So we'll delve into that.
I really enjoy what I do here.
Yeah. Excellent. Thanks again for joining. We'll delve into a lot more into what that new paradigm is all about in this webinar. Let me also introduce John Janeshig from Mirantis, who actually does a lot of cool stuff here in Mirantis, working with our partner ecosystem. He was the architect behind today's demos that you're going to be showing. We're going to be showing you shortly. So John, tell us a little bit about your experience with Cloudfoundry. And I know you've been working with Cloudfoundry and Openstack for a few months now. Any tidbits you want to share before we get started?
Well, what I have been reminded of again and again in working with Cloudfoundry is how similar the visions of Mirantis for OpenStack and Pivotal for Cloudfoundry are. As you'll see in the upcoming slides and demonstrations, what we're really talking about is bootstrapping up from bare hardware to a place where you can deliver, where coders are empowered and DevOps can really happen and enormous value can be delivered, and time to value can, of course, be minimized.
Perfect. And welcome, John, once again. We hope to have a great session today. We'll keep it fairly interactive as we go along. And if you go to the next slide, the audience, thanks for joining us today. Good morning, good afternoon, good night, wherever you are. Thanks for joining us today. You can keep asking questions as we go along. You can submit the questions in the questions pane you see on the screen. And at the end of this broadcast, we will make sure you'll have the slides and the video and a whole bunch of other things that you can follow up on. So keep asking questions, and if I find something interesting in the question pane, I'll bring it up as we go along. Let's get to the agenda without any further ado. Next slide. So here's what we're going to cover today. Very quickly, I will cover the whole value proposition of OpenStack and Cloudfoundry. Why is these two things coming together a great thing for you? What problems does it solve? How it's changing the industry. So with that, I will hand it over to Ryan. At that point, he's going to walk you through Pivotal Cloudfoundry, what it is, what are the benefits of it, and then John is going to talk a little bit about what we have done to make Cloudfoundry work on OpenStack. So there are a number of things you need to consider in terms of best practices and configurations, etc. So he's going to walk you through some of those key elements, and then we'll jump straight into the demo. We have a couple of very exciting demos for you today. One is, of course, how to deploy Mirantis, Pivotal Cloudfoundry on Mirantis OpenStack. The teams have worked very hard over the last 2 to 3 months in making that whole thing a very seamless experience, and you'll see what we mean by that. It's a fairly straightforward exercise. Everything has been automated to the extent that it makes it very easy for you to get both systems up and running. And then we have another demo about Cloudfoundry itself, how it is self-healing, and there are a number of great features in Cloudfoundry that appeal to web-scale and cloud-native developers. We have a short demo that shows you how an application is resilient and it is self-healing. So we'll show a short demo about that, and then we'll leave it open for Q&A towards the end. We expect to see a lot of interaction. Feel free to ask us questions as we go along. Next slide. So let me first give a quick introduction about what's going on in the industry and why this is such a big deal, right? So what's happening today, if you look at the landscape, the industry landscape in IT, we are in the middle of an unprecedented transformation. So there's mobile, there's big data, There's all these cloud infrastructures that are coming up in response to heavy demand and the need to be very agile and flexible. So that's seeing a major change in the data center. You know, when you look back into the data center of the last 20 years, highly inflexible, very hard to change. It's not open, it's proprietary. You're kind of locked into various vendors that you're using. So that's one challenge on the data center side and infrastructure. And on the other side, you have quote-unquote legacy applications or classic applications that aren't really designed to scale or aren't flexible enough to be able to respond to great customer demands and fast-changing responses. So application modernization is a key kind of driving factor. And then finally, we hear so much about DevOps. I mean, at the end of the day, it's all about agility, right? If you want to respond to a customer requirement quickly, almost in real time, you should be able to develop your code, push it, test it, develop it, test it, deploy it, and get it into production as quickly as you can. And that's really the goal of DevOps. So you're working with your developers and your operations folks and making that whole continuous integration, continuous deployment a seamless experience. That's really what this marriage between Openstack and Cloudfoundry is going to give customers and users. Next slide. So let's look at the communities, right? So Openstack and Cloudfoundry are both open source communities. Now, this slide is from 2014. It's about a year old, but things have actually changed a lot more since then. But the main point in this slide is both Openstack and Cloudfoundry are #1 and #2 top open source cloud computing communities out there. And there are a number of ways of slicing and dicing this, but just look at the number of contributors, the momentum behind the communities, the number of founding companies, there are foundations behind it, and there's a lot of momentum. There's no question about it. These two communities are the top 2 communities in open source. So if you look at the next slide and what Mirantis and Pivotal are doing, so Mirantis is a top contributor to OpenStack. We drive almost all of the core projects in OpenStack, whether it's Nova, Cinder, Neutron, Ceilometer, et cetera, et cetera. And we are also very, very active in the Ceph community upstream, although that's not OpenStack. It's still a key part of our offering, software-defined storage using Ceph. But more importantly, we lead a number of innovative projects upstream, things like Heat. We are #1 contributor to Heat, Murano, Sahara, Rally, and so on. And we have our own deployment tool, which is Fuel, which is also an open source project, not yet part of the OpenStack tent, but soon to be, hopefully. So we're working on that. And we also happen to be the #1 bug fixer. I believe it's in Liberty at 1,110 fixes. So clearly, we are, one of the main contributors and active participant in the OpenStack community. Next slide, and you see the same kind of dynamic with Pivotal. Pivotal is a founding force behind Cloudfoundry, and they're #1 contributor to the Cloudfoundry Foundation and to the Cloudfoundry community. And more importantly, Pivotal is actually, Cloudfoundry itself is a pretty popular open source platform as a service platform, if you will, used by a very large number of companies, whether it's startups or even you see some of the biggest names in the industry here: Verizon, Mercedes-Benz, Philips, Comcast. I mean, it's the list goes on, and we have a number of mutual customers, Pivotal and Mirantis, and we're going in there and making this this joint value proposition possible. So if you go to the next slide, the reason why this all is great is the result of this partnership is basically you're getting a complete end-to-end, top-to-bottom, open cloud-native system, right? So you're not locked in. You have open infrastructure driven by OpenStack, and you have an open platform as a service, the application platform driven by Cloudfoundry and Pivotal. So with that, I'm going to hand it over to Ryan, who is going to walk us through some of the fundamentals of Pivotal Cloudfoundry and some of the benefits we get from it. Ryan, take it away.
Yep. Thanks, Kamesh. So I want to reiterate first the problem statement that Mirantis and Pivotal are ultimately solving here. At Pivotal, we see the problem as this, that there's a growing pressure for IT businesses everywhere to deliver software on the cloud as their main vehicle for business value. and to do it quickly. But we can't take full advantage of the cloud unless we have a cloud-native approach to how we build software in a scalable and portable way. So that requires a transformation in all aspects for the IT industry. And there are several key trends that we recognize to be a part of that transformation from the perspective of the application development process. So any platform that we might dream of for the cloud-native future, it needs to support all of these trends. Those trends are DevOps, continuous delivery, microservices, and containers. And while containers are becoming commonplace across all cloud platforms, there are no other platforms out there that fully address the needs of these other important trends. So next slide. Next slide.
We are on it.
So let's go into a little, so we're going into a little more depth for these. We can think of DevOps as solving the, well, that's not my problem response. Or in other words, whenever you find yourself stuck in an organization that has siloed off each of its teams, for instance, system admins, developers, QA, etc., and as a result, each team is simply tossing over the wall their deliverables to other teams and not focusing on the ultimate common interest. So DevOps is all about tearing down these walls and creating shared tooling, shared culture, shared incentives to make the overall process much better, much more agile, so it can deliver quickly and reliably. Continuous delivery, on the other hand, addresses the problem that I know many IT organizations face where the release cycles are simply too infrequent to keep up with the demands of their users and customers. It becomes a problem with this terrible snowball effect when your users come to expect that you're just going to take a very long time to deliver on their requests. So they'll try to pack as much scope as they can into each release cycle, which prolongs releases even more and increases the likelihood of bugs and poor quality code. Plus, you'll just lose out to your competition if you're not able to deliver functionality fast enough. And then from an architectural perspective, we've seen monolithic technologies do not work well in the cloud. They don't scale easily, nor are they portable. And they're a major reason why we have these longer release cycles in the first place, because each development cycle is followed by integration testing of the entire monolith. Downtime is also very difficult to avoid. When I was an application developer for a huge IT enterprise, I remember we would have to come into the office on late nights during weekends and do releases during non-business critical hours because those deployments were so large and so complicated that downtime was inevitable. Microservices, on the other hand, being an architectural approach that allows you to decompose your monolith into loosely coupled services, is the right choice for a cloud native. So all we need now is a platform that enables us to harness the power of all of these ideals. Next slide. So the platform that we have to meet the demands of cloud native's opinionated approach to building software is a pivotal Cloudfoundry. And the solution that we propose here has multiple layers. So taking a look at the center column of this slide, we'll start at the bottom layer with our infrastructure, which in our case is Openstack, but it could really be any infrastructure that we choose. Then there's the infrastructure automation level, where all the virtual machines are being managed. And similarly, above that, the runtime platform is where all containers are being managed. Finally, we have an application framework that helps developers accelerate how they can build and reuse microservices. On the left-hand side, you'll see where each team is involved, with the operations and development teams both collaborating at the runtime platform level. And on the right side are the tools that we provide as real answers to these abstract ideals at every level.
So Ryan, I have a question on this. So if you look at this slide at the bottom, you have multiple infrastructure platforms like AWS, VMware, and OpenStack. So I guess the question I have, and there was a question from the audience I think is kind of timely to ask, is how portable, so if you wrote an application in Cloudfoundry using Bosch or whatever, this framework, how portable is that application across these different clouds?
It's seamlessly portable. So there's no difference in how you would deploy or run this application. As long as it's on Pivotal Cloudfoundry,
Right.
you could run that on AWS, VMware, OpenStack, and actually Azure's in the pipeline as well for us.
Yeah.
But yeah, it's completely seamless.
So the reason I bring up that question is, when I started off the webinar, I talked about no lock-in, and
Right.
this is an example of, well, first of all, there's no lock-in to any particular provider, so you're not stuck with VMware or OpenStack or any of these, but you have the choice of putting the right workloads on the right cloud infrastructure of your choice, which is really all about choice, no lock-in, and the ability to move your workloads as you need it, right? So that's kind of one of the key value propositions. And just so, since we are on this topic, I also want to say that Mirantis has done some integration with VMware at the infrastructure level. So you can actually have KVM clusters and VMware clusters all managed through OpenStack, on top of which you can run Cloudfoundry. So just want to take a quick tangent there to answer that question. Go ahead.
Okay, thanks. So on the next slide, we'll see the application framework. And I just want to briefly mention as well, here are some neat tools that are also open source and where Pivotal is also the #1 contributor. And we all know Java is pretty dominant in the enterprise space, so I think it makes sense to talk about it a little bit here. Most of you are probably familiar with the Spring framework for building Java apps. And Spring is full-featured, so as a result, it can be a bit complex for many developers. And that's where Spring Boot is the perfect tool in that it provides an opinionated approach which simplifies away the complexity of a full-featured Spring by focusing on convention over configuration. It's really pretty amazing how Spring Boot has surged in popularity. We're getting now, I believe, 1.6 million downloads per month, and that has grown by a factor of 8 since April of last year, which is pretty awesome. So why is it so popular? We see developers love Spring Boot. It's zero config, super lightweight, and just overall it makes it very easy to build Spring apps and just run them. And complementing that is Spring Cloud, which is a collection of components that help you build distributed apps for the cloud. Netflix actually solved a bunch of these problems at web scale on their end, and their open source stack is really great and very interesting to learn about, but it's not so easy to use. So we at Pivotal took that core functionality and we built Spring Cloud. So all the power of Eureka, heuristics, and config server, they're now all at your fingertips. All that power built into Spring modules. So now it's as easy as just adding a couple annotations to your code and you're ready to go. It's so awesome that Netflix is now using it, and we see application developers everywhere able to make lots of microservices and tie them together to make these amazing apps, all with Spring Boot and Spring Cloud. So this is all a great story for application developers. Let's look into how we can now make operators' lives easier. Next slide, please. So Spring Boot, Spring Cloud, great. We can now create apps really quickly, but now once we have our app launched, everybody's going to start asking the day 2 questions, which are all centered around the question of, well, now that I'm running, how do I ensure that I stay running? So how do you do logging? How do you gather performance metrics? How are you going to scale to meet demand? How are we going to implement self-healing? And just overall manage the life cycle of all of these apps. Developers and operations teams alike would just like to see these problems go away. So that's where Pivotal Cloudfoundry Runtime comes in, which is our application runtime platform. This platform includes containerized app deployment, management, and scheduling, but it's also much more than that. It takes more than just a container management platform to define a cloud-native platform. So it also comes with integrated agentless logging and application performance metrics, self-healing. So when an app instance goes down, the platform will immediately bring it back up automatically to maintain a desired state of your system. And auto-scaling. So you can tell the platform to scale up or scale down and then maintain a new number of app instances, or simply respond appropriately to situations where the application is being overloaded and needs to increase its instance count. And you get all of these neat features with very minimal human operational overhead. So I want to give an example here. We at Pivotal have a public cloud service that we offer called Pivotal Web Services, where we're running thousands of apps and tens of thousands of containers, all with a team of 6 people, which is incredible. That's thousands of apps, six people. We're very happy with that. And of course, we're using Pivotal Cloudfoundry to do it. And I think you would all be very happy with that as well. But stopping there isn't enough. There's actually more. Next slide, please. Next slide. Yes, thanks. So we need to orchestrate the infrastructure to support this runtime. Cloudfoundry tells the infrastructure what to do, and it has a common API to support various infrastructure types, for instance, AWS, vSphere, and OpenStack. And Bosh is an amazing infrastructure tool. It's not like Puppet or Chef, which are simply provisioning environments from configuration. Bosh goes the extra mile to maintain a desired state of your infrastructure. That's why we call this layer infrastructure automation and not simply infrastructure abstraction or infrastructure provisioning. So imagine if you could easily avoid both planned and unplanned downtime with your platform. So when you're patching all of your VM's operating systems, for instance, for a security vulnerability, you don't need to bring the system down. Bosh will simply manage a rolling upgrade to take care of this, such that your apps never go down. And the VMs are still all patched successfully. And then, in the event of an unplanned failure, the system is also capable of healing itself in that scenario. What I'm describing here is a world where there is no more dialing through an IT ops phone tree, no more opening tickets, no more adding VMs, creating VM templates, or manually upgrading operating systems. This is all automated, and Cloudfoundry takes care of it. So that gives you zero downtime, and all with a system that requires very minimal maintenance, all with the help of this amazing operations time savings platform. Next slide. So with Pivotal Cloudfoundry, you also get a lot of choices and customized options, particularly in these 3 areas. So what type of app do you want to run? Is it a .NET app that needs a Windows-based container? Is it a Docker-based app? Or just any straight-up application in whatever language that you want? So out of the box, Cloudfoundry provides support for these languages through what we call build packs. Build packs let you push applications so that they just simply work. You can run apps in Java, whether it's Rails, Play, or Spring frameworks, Node.js, Ruby on Rails, Sinatra, Golang, all with the default build packs. If you need another language, there's probably a community build pack out there that you may use, or you can write a custom one.
Ryan?
Now, if your applications require, yeah.
There's a question. So if you build an application using these services or connecting with these services, or you're using some language packs, how easy or hard would it be to kind of move away from the app once you've done it in the Cloudfoundry? In other words, again, portability question, right? Are you tying in yourself into a Cloudfoundry environment when you know all these application dependencies and service dependencies? I guess is the question. Is how much are you locking yourself in?
It's just one command that you have to run to bind a service.
Yeah.
You could, and there's very little config that has to be done, so it's quite easy.
So if you take your app from, well, I guess you have to stay in the Cloudfoundry environment, right? You can change clouds, you can change services, but your app doesn't need to change.
Correct. Yes.
Okay. Okay, cool. Thanks.
So yeah, as I was saying, the applications, if you acquire a database or other services, then there are plenty of options to choose from within Pivotal Cloudfoundry or from our partners ecosystem. Developers can get role-based self-service access to databases like MySQL, messaging services like RabbitMQ, mobile app tools like push notifications, continuous integration tools like Jenkins, and much, much more. So you can also build services of your own. It's a very extensible platform. And finally, we also support multiple infrastructures, of course, as I mentioned before, including Mirantis Openstack. So with that, I'll turn this over to John, who will show you how to actually deploy Pivotal Cloudfoundry to Mirantis Openstack.
Thanks, Ryan. Our goal, we've been working with Pivotal for the past almost 3/4 of a year. We began with, in fact, Community Cloudfoundry 1.4 back in the first quarter, making that work on Mirantis OpenStack 5.1 and 6.0. That was a much rougher process than our more recent experience with Pivotal Cloudfoundry and Ops Manager has been. If any of you have experience with Community Cloudfoundry deployments, you know that they are based around the use of hand-configured YAML files, which increase in complexity as the sophistication of a deployment increases. They're not super difficult to work with. It's certainly a learnable skill, but what Pivotal has fronted in the way of automatic deployment and web-based configuration with Ops Manager, overlaying the Bosch infrastructure, is a huge step forward, and we found that not just reliable, but actually pleasant to deal with. Our goal in putting Cloudfoundry in several Mirantis laboratory and larger data center situations, and in Pivotal's putting Mirantis OpenStack in their own laboratories, has been to build up our compatibility matrix, and this is going to be an ongoing commitment that we make to ensure ongoing viability version by version. This is, as you can imagine, challenging, particularly since Pivotal's releases are even many times quicker than OpenStack's 6-month cadence. We have released today a reference architecture, which is really what we are pointing you towards. What you'll see in the next 10 or 15 minutes are some highlights of a longer and more necessarily more complicated process. The reference architecture shows you that process in great detail, and you can get that by going to the URLs that we'll present to you after this webinar concludes. The vision, though, as I said at the beginning, is a relatively simple one. We think that with Mirantis OpenStack and Pivotal Cloudfoundry, we have the basis for bootstrapping an entire infrastructure that allows programmers to be maximally productive and allows DevOps to happen. And doing so with a little bit of practice in something under half a day. Really, a long morning is all you need to go from bare hardware to a fully functional, robust production scale IaaS with Mirantis OpenStack and Fuel, and then another couple of hours will get you to a working platform as a service system, and you can put your programmers pretty much in charge of it after that with a few checkouts. And Ryan is not kidding. They will have virtually instantaneous access to all of the infrastructure that they expect to see in a full continuous integration, continuous delivery system. There is a very compelling little 30-minute demo that Pivotal does as part of one of their training classes.
So, John, one quick question.
Yeah, sure.
So the Ops Manager has been really enhanced in the past release 1.6, where it really works well with OpenStack and deploys Cloudfoundry in almost an automated click button fashion, right?
Yes.
Compared to what it was previously, which was a whole bunch of manual instructions. And I remember, John, you had created a reference architecture with pages and pages of manual CLI commands, and it was all very error prone. Now it's all pretty easy, right? Can you talk a little bit about that?
Well, I can do better than that. Is I can show you how easy it is.
Perfect.
We have a demo
Okay.
coming up. So why don't I proceed directly to that?
Awesome.
In that demo, we'll be touching on some of the issues that we dealt with, some of the questions that we answered, and how to create a production Mirantis OpenStack cloud to host Pivotal Cloudfoundry. Primary among these are considerations of scale, which will necessarily get short shrift in a 10-minute highlights reel demo video, such as I'm about to show you. How to plan around storage, things to do about the security context, particularly the security used in front of OpenStack APIs. Preparation of tenants to host Pivotal Cloudfoundry, which can indeed be hosted in individual OpenStack tenants, not just at top level, and some tips to facilitate more rapid deployment, including how to create jump boxes and other small-scale tooling that speeds up the process of getting Cloudfoundry to work on OpenStack. So without further ado, let me get to the
John,
demo.
Before you jump to the demo, I think there's a question here that's pertinent to what you're talking about here. The question is around segregation of workloads. Do you build multiple cloud foundries on a single OpenStack cloud, or do you have one large, cloud foundry that is segmented for various workloads? I mean, either Ryan or John, one of you guys can try and answer that one.
I can try. Actually, you can do both. There may be situations where you want to run multiple cloud foundries in individual OpenStack tenants, and I'm sure that can be made both scalable and efficient.
Yeah.
The tenant framework of OpenStack lets you strictly control the resources to which a particular Cloud Foundry instance has access, and that may be operationally useful. But on the other hand, Cloud Foundry has a highly articulate, internally secure structure for creating various metaphors that are equivalent to tenants in their cosmology, including spaces, for example. So there are lots of tools inside Cloud Foundry for segregating workloads by resource, controlling access by users, permitting useful sharing, and of course controlling access to those back-end shared resources like MySQL databases and Redis.
Because it depends on the level of security and network and traffic management and isolation that's required by the customer. I think the short answer is there are different ways of doing it. You can certainly use tenants, as John was mentioning, within OpenStack, which gives you some of that at the infrastructure layer. And if you want that level of infrastructure kind of isolation, on the other hand, you can also do it within Cloud Foundry. We can kind of do this a little bit later, John. Let's jump straight into the demo. There are a number of questions we need to get to.
This short video demo shows highlights of an evolved deployment of Pivotal Cloudfoundry 1.5 on Mirantis OpenStack 7.0 in a scalable configuration designed for small-scale production. Implementers wishing to pursue similar deployments should download our Runbook, installing Pivotal Cloudfoundry on Mirantis OpenStack. The Runbook is designed to complement Pivotal's own fast-expanding deployment document series for OpenStack IaaS. With Fuel's web UI, we can explore one of the high-efficiency OpenStack clusters we created to work with Pivotal Cloudfoundry. As we can see, the 4-server cluster comprises one controller deployed in HA configuration, but lacking the additional mirrors required for full HA operation, and 3 compute storage nodes, each with a Ceph OSD. The cluster as a whole gives us 36 physical cores in compute, which is ample to run the 64 vCPUs we need at deployment peak. It gives us 156 gigabytes of RAM in compute, which accommodates the calculated 175 gigabytes RAM we need at deployment peak with some oversubscription, and available storage, in this case SSD, to ensure solid Ceph performance in all modes is greater than the calculated 1260 gigabytes we'll need at peak. Fuel shows how we've set up our nodes with one controller and 3 compute Ceph. In the Storage Setting tab, we can see how Fuel has set our Ceph storage up by default. If we were using separate nodes for Ceph storage instead of combining storage with a compute function, we would have unchecked Ceph RBD for ephemeral volumes, permitting local storage on computes to be used for this purpose. On the public TLS tab, you can see the only non-default setting we've made to this environment, turning off Fuel's standard choice of TLS for OpenStack public endpoints, because that would have required us to configure DNS to serve the cluster and obtain valid certificates. For a full production deployment, you should do this. Looking inside our deployed OpenStack cluster, we can see some of the preparations made to accommodate our Pivotal Cloudfoundry deployment. Here in the glance image list, you can see Pivotal's Ops Manager distribution image and 2 stem cell images, one deployed to support microBOSH, the other required for VMs hosting Elastic Runtime components. On the Project Access and Security Groups tab, we can access the rules for the Ops Manager group that houses Pivotal components. To Pivotal standard rules, we've added an egress rule for all ICMP, letting Pivotal components use ICMP to prefetch IP addresses from DNS for its critical endpoints. On the Instances display, we can see the Ops Manager VM launched and given the floating IP we'll use to access it via browser. In object storage, we see the PCF bucket used to store Ops Manager binaries, proof that we can configure Ceph to use Keystone authentication and work under OpenStack's S3 API. We used internal object storage for Elastic Runtime. The network layout for the project is impressive. Look at all those Elastic Runtime component VMs. Opening Ops Manager in a browser, we can look at configuration of the 2 tiles in our deployment, Ops Manager Director and Pivotal Elastic Runtime. Both tiles are green now because they're fully configured and deployed. Initially, they're color-coded orange. The first thing Ops Manager needs to know is the Keystone endpoint, which we can get along with other endpoints from Horizon's Access and Security API Access tab. Other basic info include the OpenStack Administrator or Project Bin login and SSH key. On the Director Config tab, we've supplied Amazon Time Server URLs, and in this case, designated OpenStack as storage for binary blobs. Our Runbook contains a tweak to enable this with Ceph as the storage backend. Information about the cluster project's networks are supplied under the Create Networks tab, the network name and ID, easily found in Horizon's Network tab, and IP addresses to exclude on the subnet. That's most of the configuration-specific details required. Pivotal's documentation covers a few other requirements, and then you're ready to click Apply Changes to deploy. You can see the Ops Manager Director deployment logged here. When deployment completes, we're ready to configure Elastic Runtime, which has been uploaded to Ops Manager, and its tile added to the current deployment using left-hand controls. Under File Storage Config, we've selected internal object storage this time, not the production choice, but it works fine too. Under Security Config, we're telling Ops Manager to generate self-signed certificates for Elastic Runtime instead of supplying formal wildcard certs of our own. Specifying the wildcard URL correctly here is important. It starts with star.system, and in our case uses the floating IP we've reserved to assign to Cloudfoundry's HA proxy load balancer entry point, and concludes with exip.io, which we're using instead of setting up our own wildcard DNS. Under Cloud Controller Configuration, we supply what will be Cloudfoundry's system and apps subdomains, again constructing these around the HA proxy entry point IP and the exip.io trailer. The most important tab, Resource Configuration, lets you scale your deployment in great detail, designating VM flavors used to host components, volume sizes, and critically, providing the HA proxy component with its designated floating IP, which becomes the subdomain entry point for all cluster operations. If you have some capacity overhead, you may wish to increase the number of compiler VMs to speed deployment. Our Runbook contains a chart of recommended values for items enumerated on the Resource tab. Finally, the Stem Cell tab shows where we needed to download and then upload a stem cell prepared cloud image compatible with this version of Elastic Runtime. Once that's saved and the tile turns green, you're ready to return to the dashboard and click Apply Changes to deploy. The deployment of Elastic Runtime takes quite a bit longer than Ops Manager Director, up to 2 hours. Once deployed and smoke tests complete, it's time to log into your new Pivotal Cloudfoundry cluster. To do this via the Apps Manager web UI, obtain the admin credentials from Elastic Runtime's Credentials tab in the UAA section. Visit Apps Manager on the system URL console.system.domain. In our case, we use the HA proxy entry point IP plus exif.io here, and log in. You can create user accounts, domains, spaces, and administer system functions like scaling from this UI. Finally, go to a terminal and CF target, then CF login to your Pivotal Cloud Foundry. We've already logged into ours, so it remembers our cluster's target URL. Then to celebrate, you can CF push something simple, like this little PHP application. Watch Pivotal Cloud Foundry identify the language, select the appropriate build pack, upload components, build the droplet container, and launch your app. Finally, you can test your app by visiting it on the supplied URL on your cluster's apps subdomain. Okay, I think I'm back. Sorry for that rough transition. That was obviously the 10,000 mile an hour view of what it's like to deploy these systems. The reference architecture goes into a great deal more detail, and as a companion to Pivotal's documentation, should give people everything they need in order to bring up a working production cluster. Now we have another demo, which Ryan will hopefully narrate, because I can't show the video and narrate at the same time, which shows some of Pivotal Cloud Foundry's self-healing capability. Basically, what we have is a small app written in Ruby that we're going to push 2 copies of, and all this app does is report to a browser what port it's talking on. So by refreshing a browser window, the load balancer will hand off your calls to one or another instance of this app, and they will duly report their ports. We'll then break the app. We'll break one of them at random. We'll watch as the ports returned become singular, and then we'll watch as they become doubled up again as the second instance is automatically revived. Ryan, if you would be kind enough, I will proceed to that demo.
Yep, sounds good. Thank you. Okay, so as John said, this is a simple Ruby app that we're going to be pushing, and we're going to be pushing 2 instances of this app. So here we are in the terminal, pushing that app 2 instances, and it's going to that space that we specified. We're uploading the files for that app. And now it's downloading the appropriate Ruby build pack. Okay, and now we're running. So you can see here we have 2 instances of the app that are both running. So let's head over to the browser, or sorry, let's start tailing the logs and making sure that the app is up. And you can do all this through Apps Manager to view the status of the app. However, we're just doing it in the terminal here. So we can see in the logs that the app is indeed running. So now let's head over to the browser, and we'll get the route to that app from the logs. So in the browser, we're hitting the main route, and we'll see the response from the app, which is just hello world, and it's noting the port that it's reporting from, which in this case is 61047. So let's remember that for a minute. So the system is going to load balance your request to the instances of the app they're running. So now we see 61046 when we refreshed that route in the browser. So 61047 and 61046 are the two ports that we're using. So now let's actually tell the app to break itself. And so this app has a kill switch built into it. So we just access the /broken route. So now let's revisit the main app URL and see what happens. So we can see that the instance with port 61046 has survived. And we're going to refresh a couple of times until the other app instance has revived. So now we see there's a new instance with 61048. So that the instance that was killed was the one on 61047. Let's break that again and see it happen again. So we we go to the /broken route to kill the app instance. And we can also check in our terminal the command what the current status of all of these apps instances are. And now we'll watch as that one restarts. So now we see that the instance at port 61046 just survived, and now there's a new instance at 61049. So that's the demo. Thanks for watching.
Thanks, Ryan. I guess that was the demo time. Wanted to show you some real stuff that we have been working on over the past several months. It's time for Q&A. We have about 10 minutes. There are a number of questions that have come through, and at this time, please feel free to go to your questions pane, ask as many questions as you can. We'll try to answer as many as we can in this session. And those that we cannot get to, we will come back with a blog post answering those questions. So let me go through some interesting ones here. I guess this one is for you, Ryan. The question is about how to cover differences between using a build pack, example using Python or Django, versus using Docker, right? In the case where a build pack already exists for your dev environment. So what are the pros and cons of using one versus the other? And are there different CF feature sets, these two use cases apart? So in other words, Docker and app build pack. What are your thoughts on that?
Yeah, so with the build packs, I mean, these are completely built within the Cloudfoundry community. And they're very extensible, and you can customize them as much as you want. Whereas with Docker, you're limited to whatever Docker features there are. In terms of how Cloudfoundry handles the differences, it's really very similar. I believe you just specify a flag in your push command, specify a Docker image file. It will run the Docker image on the platform as it would any other types of containers.
Okay, great. Thank you. Lots of questions coming in. Thank you. Keep it going. Let me pick on some interesting questions here. So there's one around auto-scaling your app instances. How do you determine which instances should be shut down when you're auto-scaling down your applications, right? I mean, is there any heuristic or a way of telling which ones to shut down?
I'm actually not sure. I will have to get back to you. I believe there is no specific determination for which instances are shut down,
Okay.
But I'm not exactly sure.
Yeah, and there's a question about day two. We talked a lot about patching and things like that. So how does that actually happen? Who owns the patching of changes to the application framework or to BOSH or any of the runtime stuff? How is that handled?
So for Pivotal Cloudfoundry, we often release patches, most frequently for security patches, to all of the CF components. As these vulnerabilities are being announced in the community, they are being patched in within those components that are open source, but we make sure that the releases are automatically updating. For instance, the operating system on the VM, if there's a vulnerability there, we'll put out a release to address that particular vulnerability, and you can simply upgrade Ops Manager or Elastic Runtime, which will then automatically deploy the patched OS across all of your VMs.
Okay, there's one on OpenStack, specifically around database as a service. Trove is a database as a service project within OpenStack. I guess the question is there a way to use that within the Pivotal Cloudfoundry context?
There are a couple of ways, and in fact, we started having a discussion about just this 2 weeks ago. One way is to wrap Trove as a service for distribution via Cloudfoundry. So basically, Trove itself is abstracting multiple database backends, and Pivotal offers a development kit and a documentation enabling wrapping of things like Trove and presentation via Pivotal's interfaces to applications. You know, I don't believe it's been done, but hypothetically, it could certainly be done that way. What would you say, Ryan?
Sorry, what was the last part?
Just you know, I know we haven't done it, but it's a kind of an intriguing proposition. It's a way of bringing a methodology for doing databases, you know, as a service under OpenStack natively into Cloudfoundry and making it available that way.
Yeah. So we provide an internal database VMs to run that support the Cloudfoundry system itself, and we're constantly looking at ways to make those services better. I know, for instance, automated backups of those databases. That's something that's in the pipeline, and we're actively investing in that.
Right. Okay. So there are questions around Murano here, John, probably for you. So the Ops Manager today, the way you're deployed it is through a glance image, right? I mean, you're kind of pulling that up and installing through a glance image. Now, conceivably, you can make that available in the app catalog within Murano and have Murano basically deployed from there, right? I mean, the question really is, what is the difference between using Ops Manager to install Cloudfoundry versus using Murano? I guess is there a community edition of Cloudfoundry that you can deploy using Murano package?
So not that I'm aware of, but I guess I'll go over the value that Ops Manager provides over deploying plain open source CF, which is that, you know, Bosh it's a very powerful tool, but it's extremely complicated because of all that power. Ops Manager is our solution to simplify how to use Bosh so that you're not configuring manifest files and using the CLI to do everything manually. Instead, you can have Ops Manager do all of that for you in an automated way.
Okay. So the concept of taking a Murano package and creating a Pivotal Cloudfoundry is really not that much of a stretch of imagination, because, you know, Ops Manager is doing a lot of the automation already. So it's a matter of making Pivotal Cloudfoundry available in the Murano app catalog, and with a push button through the app catalog, basically deploying what John just showed you in the demo. So that's probably the way that would go, right, John?
Or rather, just push button deploying what allows you to deploy to subsequently deploy a Cloudfoundry. Right. It doesn't make a lot of economic sense, I guess, to sort of try to reinvent the wheel. Where Murano plays, on the other hand, is making it possible, you know, because obviously most entities are going to want to use their OpenStack clouds to do more than just host instances of Pivotal Cloudfoundry. They're going to have many other applications working in the overall environment. Murano can deliver those apps smoothly and seamlessly and orchestrate them in various ways to give something of the same effect, including self-scaling, for example.
Right.
And it can deploy alternative platform as a service frameworks as well.
Right. Yeah, questions are coming in. Great, but we have only a few minutes left. There are a couple of questions, though, that, again, as I said earlier, we're going to answer all these questions later on in a blog post, so stay tuned on that one. You should also get a link to the slides as well as this video, everything in a few days. But I do want to touch upon a couple of additional questions here. So there was a question around whether end users can deploy microservices just like pushing apps. Ryan?
Yes. So So the Spring Cloud service, which I mentioned in the slide earlier around the application framework, that is also what we call a tile in Pivotal Cloudfoundry. It's basically another service that gets deployed through Ops Manager, which allows you to push these microservices and wire them together using all of the great tools that Netflix Openstack provides, such as Eureka, Heuristics, and Config Server.
Right. One last question, I guess. We can take one last question here. This is an interesting one, probably requires a long answer, but I thought I'd get your top-of-the-mind responses here, Ryan. So it seems like Cloudfoundry and Openstack and the whole stack that we're discussing here is great for cloud-native applications and for doing self-healing, auto-scaling, but there are also quote-unquote legacy applications that are out there in the data center. Now, what is your recommendation, or I guess advice, and what are the key points if people want to port a legacy app to a CF-compatible version? Do you recommend that? If so, what are the ways to do that?
Sure. I guess it all really depends on what your timeline is. I mean, if it's an immediate need to move that app over, then Cloudfoundry will definitely accept that application as it is. However, if you would like to refactor that app to behave in the most optimal way for cloud native, for example, implement all of the 12-factor recommended practices within that app, then it will definitely perform much more optimally and according to how the cloud native methodology prescribes. And we definitely recommend doing that if you have the time.
Okay. I think we're pretty much there at the top of the hour, but there is one question that I can't stop asking. It's actually pretty interesting. The question is around, how the configurations, I guess it applies to both OpenStack and Cloudfoundry, things like tenants, credentials, the admin setup, and so on. What happens if somebody were to mess up the setup, right? Can it be recreated from some kind of an XML file or a code file, or I guess in the spirit of in infrastructure as a code spirit, there should be a way of bringing these back up and keep the things running, right? So what happens in the Pivotal Cloudfoundry context?
Right. So I guess it depends on the type of failure. I mean, we saw what happens when containers fail. When VMs fail, then Bosch is what takes over and resurrects those particular VMs. To make sure that the system is maintaining state.
Yeah, you're talking about runtime. I guess the question is really more about the configurations of the setup itself.
Right. Okay. So yeah, those configurations are saved to persistent disk. So you can find those if there is a catastrophic failure, or if you want to resurrect an entire system from those configurations.
So they're stored as XML files or something like that, or are they stored as code, quote unquote?
So the configurations are in YAML.
And YAML.
Yeah.
Okay. Perfect. We are out of time, unfortunately. We have several questions here still that we are unable to get to today, but we promise you we'll get back to you with a blog post and answer as many of these questions as possible. So watch out the space. If you're registered for the webinar, you should get some messages from the team here, and hopefully you should be able to get more information there. So I thank everyone for joining us today. The the slides and the video will be posted. So if you have further questions, do not hesitate to reach out to us. Thank you so much. Have a great day. Bye-bye.